Bismillahirrahmanirrahim. I am Engineer Wali, researcher at Civil Department UET Peshawar. Today I am presenting a paper entitled Strain Gauge Technology in Piled-Raft Foundation System to the first international conference on recent advances in civil and earthquake engineering. In the sequence of my presentation, first of all, I will make a brief introduction to deep foundations, that is Piled-Raft Foundation and Piled-Grove Foundation. And after that, I will make a short or brief introduction to nano-strain gauge technology. After that, I will go to problem statement objectives. After objectives, I will go to methodology. In methodology portion, I will explain the progress of my work, which consists of three parts. First part, installation of strain gauges to piles, rafts in Wheatstone Bridge. Wheatstone Bridge is a special configuration of strain gauges which is used for special purposes. After that, I will explain the results of 4-pile group in which the pile has been instrumented by strain gauges, and will explain the distribution of vertical forces and also the distribution of lateral forces in the piles. After methodology portion, I will make some conclusion based on this and references. There are two types of deep foundation in Piled-Raft foundation. Along with the piles, raft also contributes to loads, while in pile group only piles takes loads. There is no contribution of raft because in pile group the raft, that is the pile cape, is above the ground surface. There is no contact between the raft and the underlying soil, while in Piled-Raft there is a contact between the raft element and the underlying soil. So it must transfer some of the applied loads to the soil along with the piles. Piles also takes loads while rafts also take loads. So if we instrument this type of system, we can find the distribution of the axial forces, lateral forces, which either center pile takes loads or the outer pile, the ends pile takes loads. Because in different types of soil, in different conditions, the load distribution is different. So we must instrument the piles so that to find these distributions of forces. Consist mainly of three parts. One is a carrier material, which is a thin file, and a wire wound in sinusoidal form, and a connections. This marrying grid or wire wound in sinusoidal form is very sensitive to strains. A minor strain in it leads to high changes in resistance in it. This change in resistance is measured and converted to required data. This is a real picture of strain gauge, which is consists of that is as it is clear from the picture. It is a thin file, a wire wound in sinusoidal form, and a connection to it. This strain gauge is installed to material to be tested. It should be noted, the strain gauge should make a perfect bond with the material to be tested so that 100% transfers of strains occur. For this purpose, we use special adhesives. There are five types of strain gauges. One is metal strain gauge, semiconductor strain gauge, capacitive strain gauge, and the other two. The above three, metal strain gauge, semiconductor strain gauge, capacitive strain gauges, are very important and is used usually. The remaining two are nowadays not used. Capacitive strain gauge is used in regions of high temperature. The working principle of strain gauge is that it assumes that strain on the object under investigation is transferred without loss to the strain gauge. As I told already, that 100% of strain is necessary to be transferred to the strain gauge. Most research works to simulate real behavior and to produce an economical solution to a problem. small-scale models are really difficult to be instrumented for analyzing their behavior. This becomes more difficult when measuring axial forces, bending moments, and shear forces distribution. In small-scale models of piles and Piled-Raft using strain gauges. Therefore, load transfer mechanism and size structure interaction of small-scale models of Piled-Raft and pile group has not been completely experimentally understood. Similarly, various factors like temperature, irrelevant strains, which affects the result of strain gauge, need to be compensated. Our objective is to find the vertical and lateral contribution of raft in small-scale Piled-Raft foundation system, usually in Piled-Raft foundation system, where raft is in contact with there are two unknowns. One is raft, load taken by raft, and other is load taken by piles. We should find either raft, load taken by raft to find the load taken by piles, or we should find the load taken by piles so that we find the contribution of raft. So it is easy to find the load taken by piles by using strain gauge technology, whether it is a lateral load contribution of raft or vertical contribution of raft. We will install strain gauges on pile using special configuration of Wheatstone bit to find the vertical contribution of a pile and a lateral contribution of pile. Then by subtracting the pile contribution from the total load applied, we can find the contribution of raft. Wheatstone bit configuration for and to dummy strain gauges. The active strain gauges are those strain gauges which is installed in which strain change occur, mechanical strain change occur, which is strain gauge 1 and strain gauge 3, while the dummy strain gauges are 2 and 4, which only compensate temperatures. No strain, mechanical strain in occur. Strain in temperature occur in all strain gauges, so temperature compensate will be occur by the two dummy strain gauges. Wheatstone bridge configuration for lateral load measurement consists of 4 active strain gauges. There is no dummy strain gauges. All the strain gauges are subjected to mechanical strain. This configuration is such that no change in lateral strains occur due to the load transfer, or strains occur due to the axial load. Now I will explain the results of pile group with 4 instrumented pile. Here, the lateral load versus displacement curve shows that the previous researchers that front piles takes more load while the back piles takes less load. But the summations of the load taken by piles is equal to the applied load. This is total load. Okay, if we sum this, the result will be equal to this. While in vertical load versus displacement curve, all the piles takes same load till about 2 mm displacement, but after that there is a tilting occur. Due to these tilts, the piles which have settled more takes more load, while the other piles takes less load. This is because of tilting of the material after 2 mm displacement, because we place loads, so there is a chances of tilting of the load. That's why. But the final summation of the load taken by piles is equal to the applied load. That's why we can use strain gauge technology to find the contribution or distribution, whether it is vertical or lateral, in Piled-Raft foundation system if we use the nanostrain technology. These are some references of which I used knowledge to know about the strain gauge technology in use small scale Piled-Raft foundation system, especially introduction to measurement using strain gauge technology. Any question?